Hello everyone, welcome back to Math 1351, more on math. Today we're going to finish up Chapter 10 by discussing Section 4. Section 4 deals with measures of central tendency and variance. Our objectives for this section are: 1. We're going to discuss central tendencies and variation, or the spread of the data. We're going to compute the mean, or the average. We're going to find the median and mode of a data set. Then we're going to approximate measures of central tendencies. We're going to discuss the measures of spread. Box plots, we're going to learn how to make box plots and use those to compare data sets over the same range. Then we're going to discuss variance and standard deviation of a data set. Remember, not everything can be described by the mean, median, mode. Then we're going to look at normal distributions. Whenever you hear normal distribution, you're talking about a bell curve. Lastly, we're going to end up talking about percentiles, quartiles, and deciles. For example, when you took the SAT test, your grade was given to you as a percentile. And we'll discuss what that means. So, let's look at two important aspects of any data set are the center and spread of the data, where they're concentrated and how far it ranges. The mean and median are the measures of central tendencies. They describe where the data is centered. They're represented by a single number, and that number describes some part of the data set itself. When it comes to the variance, the spread, we're going to talk about the range of the data, the interquartile range, which is the IQR. We're talking about the variance, the mean absolute deviation, or MAD, and we're talking about standard deviation of the data set. All of these data discuss how the data is spread out. Let's begin. So at the mean. Mean is an average. It's represented by the letter X, because that's our data set. X, and it's read X bar. Whenever you see an X with a line over it, that means it's the mean. It's the average. The formula for the average is just add up all your data points and divide by how many you have. And is the number of data points. For example, let's say we have this. We have these 4 grades. 25, 50, 60, 85. We have 4 grades. And we went to the average. So we add them together and divide by 4. So we add up all these together, we get 220 divided by 4. They're both simplified by 2. 2 goes in 220 110 times. 2 goes in 4 twice. 2 goes in 155 times. So the average of this data set is 55. All right, so that's just, y'all are used to doing that, figuring out your grades and everything like that. So, but when I was in college, I remember when we got near final exams, students would always try to determine, what do I need to get on this test to pass the course, or to make a B, or to make an A? So let's look at this example. Some of Dr. Einstein's class were asked, students were asked to keep track of their own grades. One day, Dr. Einstein asked the students to report their grades. One of the students had lost their papers, but claimed to remember the grades for the first 4 exams as being 100, 82, 74, and 60. And that the mean of all 6 of his tests, the average of all 6 of his tests, was a 69. Another thing, and the other 2 papers, they had identical grades. What were the grades of the other 2 papers? So remember, the formula for the mean is, when we have 6 grades, it's x1 plus x2 plus x3 plus x4 plus x5 plus x6 over 6. Remember, the subscript tells us which grade. So this is our first grade. This is our second grade. This is our third grade. This is our fourth grade. So we have 100 plus 82 plus 74 plus 60 plus 2 more. All right, if we add up these first 4 test grades, well, as we know, the mean was 69. We have to find these 2 values. 4 plus 2 is 6. 8 plus 7 is 15. Plus 6 is 21. So we know that these first 4 grades equals 316. And remember also, x5 and x6 were the same. So we had 2 of x5 grades divided by 6. Our objective is to find what x is. So since we have both grades are the same, we're looking for the grade. So first, since we're trying to get the x, we have to get rid of anything off the bottom, any division first. So multiply both sides by 6. Those cancel. 69 times 6 is 54. 6 times 6 is 36. Plus 5 is 41. So the bottom number is gone. So we have 316 plus 2x. So we're trying to get the x, so we'll get rid of anything that's plus or minus. Get rid of the 316. Those cancel. So we can't do it. That's 14 minus 6 is 8. 10 minus 1 is 9, so it's 98. So both grades together equals, so now to get the x by itself, we divide. Since they're multiplied, we divide by 2. Two goes into 9 4 times, with 1 left over. 2 goes into 18 9 times. So exam 5 and exam 6 were both 49s. Alright, so that's one way how we can use the formula of averages to find out what we need. Right? So get the other 2. The median. Like on a road. If here's our road, we have that big old concrete thing in the middle. That is called the median. Why is it called the median? Because it's the middle. The middle number of the ordered set. So if this is the median is the middle of the road, the median in mathematics is the middle number of the ordered set. What does ordered set mean? So we arrange the data in increasing order. Now, here's the important part. How to find the median. Oh, don't worry about writing these down because I'm going to attach a sheet along with all these, of all the formulas and the explanation of how to solve all these. So you have to write this stuff down. So how to find the median? First off, arrange the data in increasing order. So let's pretend our data is 40, 50, 50, 70, 80. Let's start with this here first, because it matters if you have an odd number of data versus an even number of data. So you arrange it in increasing order. So the second thing you do, divide the number of data, that's your n value, remember the number of numbers, by 2. So we have 1, 2, 3, 4, 5. N is 5. So divided by 2, we get 2.5. We're going to talk about, this first part is going to talk about odds. If n is odd, we have 5 numbers, that's odd. So, whenever you have an odd number divided by 2, you always end up with a decimal. Round it up to the next highest number, the next integer. Starting from the left, go to that number, that place number on your list. So we had 40, 50, 50, 70, and 80. So since this number is 3, we go 1, 2, 3. That number is your median. That number at that location is your median. Oh yeah, I forgot to tell you. Median, we use the symbol tilde. So whenever you see x tilde, you know that means the median. So that's the symbol for in mathematics. All right, so that was with with odd numbers. Let's look at it with even number of data. So we'll use the same basic numbers, 40, 50, 50, 70, 80, and we'll put one more in there, 90. Now we have 6. It's an even number. Again, the steps are the same in the first part. Arrange in increasing order. Divide n by 2. We get 6 divided by 2, we get 3. If you look at it, it's not really the middle number because the third number is 50. There's 2 numbers on this side, there's 3 numbers there. We can't do that. So, get the data value at that location and add the next number in the list. So we're going to the third and fourth spaces. So we'll get 1, 2, 3. We get 50 and 70. Add them together and divide by 2. So we'll find the average. If you have an even number, then we'll find the average. So there's the. So we have 50 plus 70 over 2 is 120 over 2 is 60. So that is our median. A lot of times when we do medians, we put a vertical line there saying that that's the middle of the data set. So we know that there's an even number of numbers on both sides. There's 3 here, there's 3 there. The last one we're going to talk about is the mode. The mode is the most frequently occurring number. In fashion, the reason I call it the mode, the fashion, the mode du jour, is because that's what everybody's wearing. More people are wearing that, higher frequency. So that's why it's called the mode. And that is just observation. So in our data set, we had, let's look at the last one. We had 40, 50, 50, 70, 80, and 90. So 50 occurs twice. So the mode is known as X dot. So the mode is 50 because it occurs the most. All right, so let's look at some examples here. Let's find the mean, median, mode. So remember, this is X bar, X tilde, and X dot. But not like it's a language. It has its own. So instead of writing mean, median, mode, we just write these symbols and we're done. So the first one. We have 60 plus 60 plus 70 plus 95 plus 95 plus 100. 1, 2, 3, 4, 5, 6. We could do it in pencil paper, but let's speed it up. Get my calculator here. So I have 60 plus 60 plus 70 plus 95 plus 95 plus 100. It's 480 divided by 6, we get 80. So the average of that data group is 80. All right, that's the mean. The median, we had 60, 60, 70, 95, 95, 100. 1, 2, 3, 4, 5, 6. We have 6. It's an even number, so that means it's going to, our median is going to be between two numbers. So we take n divided by 2. 6 divided by 2 equals 3. Go to that location. 1, 2, 3. So I get 70. Get the next one in the list is 95. Add them together, divide by 2. So 90 plus 70 is 160, so it's 165. Two goes into 16 8 times. 2 goes into 5 twice, with 1 left over. So the median is 82.5. It's the average. It's the average of these two. The mode, or the x dot, of 60, 60, 70, 95, 95. 60 occurs twice, and so does 95. Since we have two modes, we call that bimodal. All right, so that's how we do it. All right, let's look at the next example. This is a theory question. Suppose the average age of students in our class is 23.72 years of age. Can this value, can 23.72 also be the mean? Yes, because mean is the average. Can it be the median? No. I'll tell you why. Because of the 0.72. When we talk about ages in our class, we talk about 23 or 48 or 16 or 19. It's always an integer. So when you add two integers together, let's say those two, and divide by 2, 6, so it's 71 over 2 is 35.5. So it should always be a 0.5 or 0.0. So no, can't be the mean. Can it be the mode? No, because again, it's a decimal. Ages are whole numbers. So that, again, it's a conceptual question saying that, okay, can this be true, can that be true? Which you have to understand what the definition is. All right. Go to the next topic. Choosing the most accurate measure of central tendency. All right, now what does that mean? Why is that? Let's look at this example. Suppose a company claims that their salary structure is the best and that you should work for them. They tell you that there are 20 employees here at the company. The president makes $200,000 a year, the vice president makes $75,000, and the 18 part-time employees each work $10,000. Make $10,000 a year. Is the mean of the salaries the best number to use when considering this company? So let's see what that means. The mean. So we have x1 plus x2. This is the president. This is the vice president. And then 18 of these guys. These are the workers. All divided by 20. So we have 200,000 plus 75,000 plus 18 times 10,000, all divided by 20. So let's see what they claim their average salary is. So 200,000 plus 75,000 plus 18 times 10,000 equals 455,000 divided by 20 gives us an average salary of 22,750. So that's per year, per employee. Is that a good number? No. The reason being is because of these two. If we look at that, without those two big salaries, because those are the only full-time people, everybody else is part-time, they each make 10,000. So if you looked at the median, we had 200,000, 75,000, and then a bunch of 10,000s. There's 18 of them. Since there's 20 divided by 2, it's 10. Go to the 10th location. 1, 2. Well, the 10th location is going to be 10,000. Go to the next one, the 11th location. That's also going to be 10,000. So, the mean salary is $10,000. I mean, the median salary is $10,000. Also, the modal salary, since there's 18 10,000s, is also $10,000. This number's much bigger than the average, than the distributions. So the mean would not be a fair comparison to these guys because of the president and vice president. So since you'd enter the workforce as one of the workers, you wouldn't get the big 7-digit, 6-digit salaries. You'd get the smaller ones. All right. Let's look at another example. You have 9 exam grades. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which numbers, the mean, median, or mode, would best represent their grades? Well, let's see. The mean would be 30 plus 35 plus 40 plus 40 plus 92 plus 92, 93, 98, 99, since there's 9. Let's see what that's going to be. So we add 30 plus 35 plus 40 plus 40 plus 92 plus 92 plus 93 plus 98 plus 99. That equals 619 over 9. divided by 9 is 68.77 is 68. Okay, that's the mean. The median. Remember, we have 9 numbers, so 9 divided by 2 is 4.5, rounded up to the 5th number. So it's going to be 1, 2, 3, 4, 5. The 5th number is 92. That's your median. And the mode, you have 40, happens twice, and 92. We have 40 and 92. So which one of these three would best represent my grades? Because if you notice, you made nothing in the 50s, 60s, 70s, or 80s. You either made really low or super high. So the average of 68 doesn't tell us a true picture. The median is 92. That by far doesn't tell you because, I mean, look at your data spread. So it's more accurate if you look at the modes. You make more high and lows. You're an extremist. So again, it's which method do you choose to solve these? Let's look at another example. No. I thought I had another one here for y'all. No, yeah, I'll put it in there. Example. Suppose your grades were 40, 42, 50, 62, 63, 65, 98, 98. Is the mode a good representation of the average score? The mode, remember, mode is the most frequently occurring. The mode in this case is 98. So is that a good representation of your average? No, because most of your grades are D's or belows. So, in selecting which measure of central tendency you use, it all depends on what you're trying to prove. So when selecting a measure of central tendencies, it all depends on what you're trying to prove. Mode is good for one, median is good for another. So be very careful with that. Note, the measure of central tendencies should always be specified along with a measure of the spread. The spread of your data. Okay, that's a segue. What is this measure of spread? That's what we talk about next. So all of these go. Measures of spread. We discussed that the mean, x bar, and median, x tilde, are measures of central tendencies. That provide or give us limited information. It just tells us one specific number. To tell us how much the data are scattered, to tell us how far the data is scattered, we use measures of spread, or in other words, dispersion, or deviation. Here's another note. Even if two data sets have the same range, I'll define what range is in a second. They do not have the same spread or disposition or deviation. What is a range? The range is the difference between the greatest and the least value of a data set. So both extremes. We have A here and B here. The range is B minus A. That's what it tells us. Let's look at an example, or a small description of this stuff. We have two sets. Set 1 is made up of 1, 3, 7, 8, 10. Set 2 is made up of 1, 10, 10, 10, 10. The range is the highest number minus the smallest number is 9. The highest number and the smallest number is 9. So again, the range in this point doesn't tell us too much. So we use another measure. The interquartile range, or the IQR. So let's define what the IQR is. We'll define it with this. We have our data set. We have 20, 25, 40, 50, 50, 60, 70, 75, 80, 80, 90, 100, 100. We see the range of this data set. The highest is 100, minus the lowest is 80. So remember, this is an interquartile. So first, find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n is 13. Divided by 2 is 6.5. So our median is in the 7th location. 1, 2, 3, 4, 5, 6, 7. Remember, so since that's our median, we put a line there. There are even numbers of both sides. Now, the lower and upper extremes, that's what we used to find the range. The lower and upper extremes. This is the lower extreme. This is the higher extreme. And this is our quartile, or our median. Now, we have to find our upper and lower quartiles. What we have to do here is, on the lower half and the upper half, we have to find the medians there. The lower half of data, find its median. So we have 1, 2, 3, 4, 5, 6. N equals 6. So remember, since it's an even number, we go to the 3rd location and the 4th location and add the numbers and divide by 2. So 1, 2, 3. So the 3rd is 40. The 4th number is 50. Take those two numbers, divide by 2, and we get 45. So this is the first one. Is 45. This is the first median. This is our second median, and we'll find a third median over here somewhere. So this is quartile 1. This is quartile 2. Find its median. Again, we have 1, 2, 3, 4, 5, 6. N divided by 2, 6 divided by 2 is 3. So go to third and fourth locations. Get the numbers. 1, 2, 3 is 80 and 90. Divided by 2. So here's the third, here's the fourth. So this is our third quartile. Now we know the extreme points. We know the first quartile because this is the fourth quartile means fourth. So there's the first fourth, the second fourth, third fourth, and this is the last fourth. Now, the IQR, the formula for the IQR is the third quartile minus the first quartile. So it's 85 minus 45. So the IQR is 40. That tells us the spread of the averages of both sides. Or the medians of both sides, I mean. So IQR measures the spread often reported with the center medians, or measures of center tendencies, or the center medians. Now, what that means is the way this report should be reported, this data set should be reported, it should say, so for our data set we had 20, 25, 40, 50, 50, 60, 70, 75, 80, 80, 90, 100, and we know that 70s are, so the way we report this we have a median score of 70 with IQR of 40. Now, what do we do with these quartiles? Remember, we had the lower extreme, quartile 1, quartile 2, quartile 3, and the higher extreme. We use that information. This is 20. This was 45. This was 70. This was 85. And that was 100. We represent this by using a box plot. Or sometimes called a box and whisker plot. I'll show you why in a second. The low extremes are represented by vertical lines, or you can put dots. So this is at 20, this is at 100. Q1 and Q3 define the box. And from the box, the extremes we connect by a line. Q2, or the median of the entire set, is represented by a bar. So we know by looking at the box, we know what the first and third quartile are, and then depending on where the Q2 is, it tells us where the median is, where the center of the data is. Okay, so box plots are a way to display our data visually and help us draw informal conclusions. It all depends on what the high and low numbers are and where that box is located. It'll tell us about the spread and the structure of the data set. Yeah, so again, we have 5 numbers. The low extreme, the first quartile, the median, the third quartile, and the high extreme. Those are the 5 numbers that we deal with. All right, here's an example. So if I gave you this, how would you interpret it? The low extreme is 0, high extreme is 70, and the box, the median is at 20. That's the middle of the road. And the first quartile is at 10, third quartile is at 35. Now basically, if I were to analyze this, these are grades. The student low grade is 0, can't make it any lower than that, and the high grade was a 70. Because of this bar is very long, that means the majority of the data falls in this range. So the student is relatively a grade of 20 student. Because, I mean, from 0 to 20, from 20 to 35, that's not that good of a range. So again, this is all skewed low to the left, and it represents majority of the students' grades are towards the lower end. Now, within these, when we deal with IQRs and box plots, we can't talk about outliers. Outliers are values that are widely separated from the rest of the data set. Kind of like here's the rest of the majority of the data set. There's one way back here. What if the student made a 90 on one test? That would be considered an outlier. Well, we're going to discuss that in a second. So that's an outlier. Values that are widely separated from the rest of the data set. So we use any value that is more than 1.5 times the IQR. Remember, IQR is Q3 minus Q1 above Q3 or below Q1. So let's look at this example. The IQR is Q3 minus Q1, which is 35 minus 10, which is 25. So 1.5 times 25. One 1.5 times 25, 37.5. So any number above Q3 by 37.5 or below Q1 by 37.5. So let's see what that means. Because we know Q1 is 10. 10 minus 37.5 is a negative number. So 0 is as far as you can go, so that doesn't work. There's no lower end. How about Q3? That's 35. 35 plus 37.5 is 72.5. So if it's greater than 72.5 out, then it's an outlier. This number just barely reached it. If it was a 75, that would be an outlier. So anything greater than 72.5 out is an outlier. All right, now, next topic. Oh, let me do this example here. Let's find the IQR here. You have the Olympics from the 2016 Olympics. All these countries. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. N equals 20. So the median would be 20 divided by 2 is 10. So we go to the 10th location. Start from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since it's a whole number, go to the next number, 22. So this number here is 21.5. That is our Q2. So it means we have 10 numbers below that number and 10 numbers above. So n equals 10. 10 divided by 2 is 5, so we'll go to the 5th and 6th locations. 1, 2, 3, 4, 5. That's 15 plus 17 divided by 2, give us 16. So Q1 is 16. 1, 2, same thing here. So go 5th, 6th. 1, 2, 3, 4, 5 is 42 and 42. Q3 is 42, since they're both the same. So this is the high extreme. This is the low extreme. $10, $20, $30, $40, $50, $60, $70, $80, $90, $100. $110, $120, $130. So our Q2 is at 21.5. Q1 is at 16. Q3 is at 42. And the lowest is 10. The highest is 121. But remember, the IQR is Q3 minus Q1. So it's 42 minus 16. Hello?
Maybe, Arthur?
Yes.
Okay, I'm gonna get started out here.
Okay.
The caretaker just got here, and I asked her about the check, and she said she don't know where it's at.
I know. Yeah. If she just got there, she hasn't been inside the house yet. So don't worry about that.
Okay.
There-
All right. I just really want to let her know that I'm here, so I don't have to start her or anything. You know what I mean?
Yes. All right. Bye.
Okay,
Bye.
knock this out.
All right. Thank you. Bye.
All right, buddy.
Sorry about that, everyone. Okay, so and the next one is at 70. So I'm thinking that that's what it's going to look like. This is going to be an outlier. Because 42 minus 16 is 26. 26 times 1.5 is 39. So anything above 39, yeah, so the outlier is the 121. That's the example of what we're doing here. All right. Ooh, now comparing data sets. What if we had two or more data sets we want to compare using the same things? Remember, so in our data sets we have to do here, we have to create or compute the 5 important values. as those are being the high and low extremes. Q1, Q2, and Q3. We need those 5 numbers. All right. So we can do it with box plots on top of each other. So here's a look at this example. We have these 3 sets of cars. Fuel size of compact, mid-size, and large cars. All for 2017. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Alright, so 10th number, 19 divided by 2 is 9.5 divided. So round it up, it's the 10th. So the median is the 10th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our median. These numbers here. That means now there's 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers on top, 9 numbers on the bottom. 9 divided by 2 is 4.5, which is 5. 1, 2, 3, 4, 5. This is Q1. 1, 2, 3, 4, 5. This is Q3. This is the high extreme, and this is the low extreme. Those are our 5 numbers. So when we look at that, we create this. The high extreme, the low extreme, the median. This is Q2. Now, from there, each of these, we create their own box plots. And we stack them all on top of each other. So looking at this and interpreting this, compact cars are super unsure, because you can get anywhere from 16 to 34 miles to a gallon, and even in the box it's closer to the higher end. So that tells you get more gas mileage, but you don't know where it's going to be. The medium-sized cars are closer to the middle, but again, they go from terrible to just pretty close to pretty good. The large-sized cars are more evenly distributed, so you pretty much know what you're getting with the large-sized cars. These other two are too wide and spread out. So that's what you do there, is take your data, create the data spread, a box plot, and discuss from there. Let's look at variation. By here we're going to talk about the mean absolute deviation, or MAD. We're going to talk about the variance and the standard deviation. These are the 3 things we're going to talk about when it comes to variance, or how much the data moves. Alright, so let's do an example here. We have 2 sets. Set 1 consists of the data 100, 80, 70, 50, 50, 10. Set 2 consists of the data set 70, 70, 60, 60, 60, 40. All right, so looking at these, what do we know about those so far? The median of this one, since there's 6 of them, is between 70 and 50, which is 60. This one's also at 60. The lower end median is 80. This is Q. That's upper. This is Q3. That's Q2. Lower end is 1. On the second set, so the IQR of set 1 is 80 minus 50 is 30. IQR of set 2 is 70 minus 60 is 10. The range of both of these sets is 100 minus 10, which is 90. 70 minus 40 is it's the highest minus lowest. Highest minus lowest. So, looking at these two sets, is that the IRQ in the first one is 30 and the range is 90, so that's pretty widespread. The other one is more condensed. The range is only 30 units wide, and the IRQ, average of both the high and low, is only 10. They both have the same averages, the same medians, so we have to go now to these other sets. So group 2 is more stable because it's more condensed, more compact. All right, now let's look at the measure of absolute deviation. So we can't tell too much with what we know so far. These are pretty close, but let's see what we can do with them. Mean absolute deviation, Matt. This is the distance from each point to the mean. What we're going to do here, we're going to see how far it all varies from the average of all the data. How do we do that? Okay, here are the steps. One. Range always set up in increasing order. Find the mean. Subtract the mean from each data point. In other words, we'll have, here's the data minus the mean. Take the absolute value of it. In other words, drop any negative signs that you see. That's what it means. Take the absolute value of each. So remember, it says it's the mean. It's the average absolute deviation. So this makes it the absolute. So now at all of the x minus x bars and divide by n. That'll give you the mean absolute deviation. Let's look at an example here. We want to see exactly how far from the middle all these numbers are. So the first thing we do, take these numbers, and order them. So 67, 67, 84, 99, 99. Now find the average. So we have 67 plus 67 plus 84 plus 99 plus 99 equals that. 2, 3, 4, 5 divided by 5. I got 83.2. So now, these are all my x's. Now take the absolute deviation. So I'm taking each one of these numbers, 67 minus 83.2, 67 minus 83.2, 84 minus 83.2, 99 minus 83.2, 99 minus 83.2. So 67 minus 83.2 will give us negative 16.2, negative 16.2, 84 minus 83.2 is going to be 0.08, and 99 minus 83.2 is 15.8. 15.8. Okay, if we take all those numbers now and add them together, what's going to happen minus 16.2. If we add these now, it's going to give us 0. The reason being because all these numbers are the same distance away from the origin, from the center, from the mean, which is why we have to take the absolute value of them all. So take the absolute value of negative 16.2, we get positive 16.2. Negative 16.2, we get 16.2. 0.8, 0.8, 15.8, is 15.8. Those are all the absolute value ones. So if we add up all those, we got 15.8 plus 15.8 plus 0.8 plus 16.2 plus 16.2. That gives us 64.8. Mean absolute value. So these are the absolute values. Now we want the mean, so we take the average of it. 64.8 divided by 5. We get 12.96. So that tells us that's the average distance from all the points to the center, to the mean. All right. So that is now going to lead us. This says now on the average. Mean is the average. That's what the M stands for. So the average distance each of these points are from the mean it varies by 12.96. Now, if we looked at our other data, if we did the same thing here with both of these, (100, 80, 70, 50, 50, 10, 70, 70, 60, 60, 60, 40. If we found the average of both of those, so it's 100 plus 80 plus 70 plus 50 plus 50 plus 10. 360 divided by 6 is 60. 70 plus 70 plus 60 plus 60 plus 60 plus 40 is also going to be 60. So this is set A and this is set B. Now this is where we do absolute value of x minus x bar. This is for set B, this is for set A. So 100 minus 60 is 40. 80 minus 60 is 20. 70 minus 60 is 10. 50 minus 60 is negative 10, but we take the absolute value of it, so it's 10. It's 1, 2, 3, another 50. And then 10 minus 60 is 50. Add up all those. 10, 20, 30, this is 50, 90, 100, 120, 140, 140. So add up all those, I get 140. Now, same thing on the next one. We have 70 minus 60 is 10. 70 minus 60 is 10. I'm getting the 60s from here. 60 minus 60 is 0. 60 minus 60 is 0. 60 minus 60 is 0. 40 minus 60, absolute value is going to be 20. So add up those, we get 20, 30, 40. Divided by 6, because we have that 6 pieces of data. 140 divided by 6 is 23.3. 40 divided by 6 is 6.6. So this is the MAD. MAD for group A, MAD for group B. So again, it tells us that group B it's more compact. It's closer related to all the data sets. Let me see if I put that down there. There. All right, next we're going to talk about variance and deviation. Variance is the distance squared from the mean to the data points. The formula for variance, when you receive, is s squared. The formula of this one is x minus x bar squared. This is, we do that with group number 1, then with data number 2, and do it all the way up to x sub n and divide by n. So we have our data numbers, we find the average, subtract them, and square it. What that does is this square gets rid of the negative numbers, but it's going to make it an inflated number. And then the standard deviation is the square root. The standard deviation is s. It's the square root of all that. Why do we do that? Because the variance squares all the numbers. The difference, once we find the difference, we square it. That gets rid of the negatives, but it makes it really big. This square root shrinks them all back down. I'll show you what I mean. If I had the number 3 and I square it, I get 9. But if I square root it, I get back down to the smaller numbers. So that's what's happening here. This one here gets rid of the negatives. So even if I have negative, so negative 3 squared is 9. But when I square root it, I can go back, because this is negative 3 times negative 3. Square root that is just negative 3. Even though you're not supposed to square root negatives. All right, let's look at this example here. So we have two groups. Find the mean, median, range. So from these we know what the range already. 100 minus 0 is 100. Range is 50. Because all from highest to lowest, 50 minus 50 is 0. There is no range. So got the range. The median. Since there are 6 numbers, divide by 2. The median is 50 in that case. And the median here is also going to be 50. And the means. 300 divided by 6 is 50. 5, 10, 15, 20, 25, 30. So it's 300 over 300. So these are both going to be 50. So we know Group A, it's 100. Group B, it's 0. So let's find the IRQ, the MAD, and the standard deviation. I'm only going to do one of them, then you do the other one for practice. 0, 0, 0, 100, 100, 100. The mean is 50. So we'll do x minus x bar. So 0 minus 50 is negative 50. That's going to be negative 50, negative 50. 100 minus 50 is positive 50, positive 50, positive 50. So if you add up all these, you should get 0. Square each number. So negative 50 squared, 2500, 2500, 2500, 2500. So 2500 times 6, 20,000. Divided by 6, you get 2,500. So my standard variance is 2,500. That's variance. Standard deviation is the square root of the variance. So square root of 2,500 equals 50. So for A, it's 50. The interquartile. So the median, this is Q2, it's 50. Q1 is 0. Q3 is 100. The low extreme and the high extreme. So the IQR is Q3 minus Q1. So the IQR of A is 100. And the MAD is also going to be 50. Because MAD, in this point here, you take the absolute values as 50 all across the board, add them together, you get 300. Divided by 6, you get... Oh. That's an example for the variance deviation. Now we're getting close to the end, I promise. Normal distribution. Whenever we talk about normal distribution, we talk about the bell curve. The bell curve looks like this. Here's your mean. That's your average. Each of these are standard deviations. That's 1 standard deviation, 2 standard deviation, 3 standard deviation, -1, because you're going backwards, it's -1 standard deviation, -2 standard deviations, -3 standard deviation. So within 1 standard deviation from the mean, 68% of your data will fit. Within 2 standard deviations, 95% of your data is going to fit. Within 3 standard deviations, 99.7. And then on the outsides, very rarely, is going to be 0.3% of your data, of your values. So now, how do you figure? What does this stuff mean? So once you find the mean, let's say the mean is 60, and you calculate the standard deviation the way we did it, and you get 5. So on your list, here's your mean. You get 60. Now, 1 standard deviation, add 5 to this. So 60 plus 5 is 65. Add 5 to that. You get 70. Add 5 more to that, you get 75. That's not right. Now going backwards, subtract 5. Subtract 5 again from there. And then 3 standard deviations, subtract 5. So again, within 1 standard deviation, we know that 68% of our data is going to fall there, between 55 and 65. Between 2 standard deviations, so between 50 and 70, we're going to have 95% of our data. And within 3 standard deviations, between 45 and 75, we're going to have 99.7% of our data. That's what that means. So here's an example. When a standardized test has to be standardized, because if it's not standardized, it won't give us a bell curve. It had a mean of 500 and a standard deviation of 100. So let's create our list. We have a mean of 500, 1 standard deviation, so 500 plus 100 is 600. 2 standard deviations is going to be 600 plus 100 is 700. And then 3 standard deviations, 700 is going to give us 800. 1 standard deviation to the left, 500 minus 100 is 400. 100 minus 100 is 300. And 3 standard deviations is going to give us 300 minus 100 is 200. Now it says, how many students scored between 400 and 600? Remember, that's 68% of your data. Or what this one says is 68% of the 10,000 students. So when you do this, convert the percent to decimal, which makes it 0.68. The word of is multiplied times 10,000. So this says move decimal 4 spaces to the right. So 6,800 students will score between a 400 and 600. How many students between a 3 and 700? Remember, that's 95%. Of 10,000. So it's 0.95 times 10,000, or 9,500. So will be 9,500. This one's going to be 6,800. And then the last one, no, next one is 200 to 800. That's this one here. That's 99.7%. Again, times 10,000, which give us 9,970. How many students scored above 800? That's 0.15%. Above the third. So after 100, this is 0.15%. So for this one, it's 0.15% of 10,000. Move it, so it's 0.0015 times 10,000, which equals 15. So 15 people will score above 800. Since the bottom end is the same thing, both extremes are 0.15%. We'll have 15 students there also, below 200. All right, so that's how you use the bell curve, the normal distribution curve. This is how teachers would use it. Suppose that a group of 200 students, so n equals 200. Ask their teacher grade on a curve. I would never do that because in law school, when they grade on a curve, even if you made 100 or 90s in the 90s, if you had the lower end, you failed. So, never ask the grade on a curve. If the teacher gave a test and discovered that the mean was 71 and the standard deviation was 7, so at 1 standard deviation, 2 standard deviation, 3 standard deviation. So 71 plus 7 is 78. 78 plus 7 is 85. 85 plus 7 is 92. Now going left, we subtract. 71 minus 7 is 64. Minus 2 standard deviations, 64 minus 7 is 57. 57 minus 7 is 50. So on a bell curve, since here's a mean, that represents your C. This represents your B, your D, and A is anything there. F is anything there. So looking at our bell curve, so 68% of your group of your students, 68% will get a C. 68% of the 200, so it's 0.68 times 200. So 16, 136 students will get a C. This part here is 13.5. So this is 68. This is 13.5. This is 13.5%. So B and D's are both 13.5%. So 13.5% of 200. That's 0.135 times 200. $27. So 27 and then also a D is going to be 27. .35 plus 0.5 is 2.5. A and F will equal 2.5%. So 2.5% of 200. So move it 2 to the left. 0.025 times 200, which gives us 5. So 5 will be A's, 5 will be 7. Set F's. And C is going to be 136. That's how we use grade with curves. Alright. Now lastly, we're going to talk about our percentiles. Percentiles decile, quartile. Percentile, 100 equal pieces. Decile is 10 equal pieces. Quartile is 4 equal pieces. So what these do, they show the relationship of one value to the other values in the data set. So, okay, now so on your test, if you had this is the percentile equals 82nd percentile. What that means is you scored higher than 82% of the other test takers. That's what it means. All right, so let me see what else. Let's look at an example. Suppose two. Let me see. I have a sheet for that. Yes. There you go. No, that's not one. Oh well, I'll write it out. Suppose two students applied for the same spot at a prestigious college. student A claimed to have finished 15th in their class. Student B claimed to have finished 40th in their class. So, which one's better? Which student would you take? So it finished 15 of a class of 50 students, and B finished 40th in a class of 400 students. Alone, by themselves, 15th and 40th. Yeah, you'd think that 15 is better than 40, but you have to see on the size of the student body. So, if the person finished 15th out of 50, then 50 minus 15, so this student was better than 35 other students. So 35 over 50 gives us 0.7. Or 70th percentile. So in other words, student A was graduated higher than 70% of her class. Student B was the 40th, then 400 minus 40. So student A graduated higher than 360 students. 360 divided by 400 equals 0.9, 90th percentile. So student B graduated higher than 90% of the students. Student A graduated higher than 70%. So student B is a better student. Again, you have to be very careful on how you use the information that you're given. You have to compare it with everything else. How does it relate to everything else? Let's look at this one. The standardized test was distributed among a normal curve, has a median and mean of 500 and a standard deviation of 100. The 16th percentile, P16, so let's look at this. The mean was 500. Standard deviation is 100. So 500 plus 100 is 600. 700. 800. Because you add one standard deviations. On the left, you subtract. 400. 300. 200. So this is one standard deviations, two standard deviations, three standard deviations. Minus 1, minus 2, minus 3. The 16th percentile, P16, is 400. Because 400 is one standard deviation below the median. All right. Now, where did that come from? Let me show you. Where's my chart? There it is. How do we know that this is 16th percentile? Because, remember, from here to here, from the first standard deviation to the mean, is 34%. The mean, this is the 50th percentile. So 50 minus 34 is 16. So this is the 16th percentile. This is the 50th percentile. And subtract 13, this is P 2.5 percentile. And you go the other way. 50 plus 34, this is P84, P86, and so on and so forth. So that's what you're doing there. So when we said P16th percentile is that, let's look at P50th percentile. P50 is the mean. So that one equals 500. And as we saw a second ago, that P of 84, 50 plus 34 is 84. That's first standard deviation above. So this is P of 84. So that's 600. That's how you could use to figure out stuff. All right, everybody. That does it for Chapter 10. Whoa, I'm so sorry. It's almost 2 hours long. Good luck, everybody.